Welcome, I'm Raymond Hoofs. I work for the European Space Agency with science operations planning of our planetary missions, and I'm going to give an overview of the planetary science missions that we have in orbit, that have been completed and are in post operations, and the ones that we are planning. So I will first give an overview of all the missions that we have, and after that I will go a little bit more into the details on the ones that I have actually worked on and the ones I will be working on, because on those I just have more detailed information about, and I can give you different views on how we are developing and operating these projects. So ESA has a whole fleet of missions in our solar system, ranging from the Sun to missions as far as Saturn, and there are other ones being developed. So if we start with the ones that are around the Sun, we have the SOHO satellite observing the Sun daily, and we have its successor, Solar Orbiter, now under development. Then we have Mercury. There we're sending the BepiColombo spacecraft in a couple of years from now, which is a big project. That's one of the projects I worked on, and we will go into a bit of detail. There is Venus Express, that has been around Venus for quite a number of years, but has now completed its operational mission and is in the non-operational phase. Also there I worked on the operations, and we can go a bit in details on that one as well. Then we have, of course, our own Earth. We have there the cluster spacecraft flying in formation to do the magnetic field of Earth, and we have Proba 2 observing as well the Earth. And then, of course, when we go out to Mars, we have Mars Express that has been orbiting there for already many years and continues to work well and is continuing to operate. And of course we have ExoMars around Mars now as well, and some future programs to have a real lander on Mars. Next we have Jupiter. There we're gonna be sending the JUICE mission to observe the icy moons. And we have on Saturn, we have the Cassini-Huygens mission, which we had a full contribution of Europe to the Huygens landing on Titan a couple of years ago. And also the Cassini spacecraft itself contains European instruments, so there's a big influence there as well. Cassini is still going around the Saturn system doing amazing observations, and the results from the Cassini mission feed very much into the JUICE mission objectives of the observing the moons of these super gas giants. Then finally there is the Rosetta mission that completed its operational mission a couple of weeks ago. Is now in the post-operational phase. Also there I've been very much involved, and I will give you some more details on that mission as well. So we will go over very quickly some of the missions that I've mentioned. Then we will go into a bit more detail on the missions that I mentioned and that I worked on. On the astronomy missions in ESA, where I work, we also operate those, but I'm personally not much involved on those missions, so that I will mention a little bit less. Before we start, I want to show you an overview video that covers already some of these missions to give you an impression.
How did it all begin? What are the origins of our planet? To understand our place in the universe, we need to explore space. Let's look at some of the missions we are using to do this. ESA's Planck satellite has mapped the cosmic microwave background, a picture of the universe just after its birth 13.8 billion years ago. The tiny color differences in the image represent seeds that later formed galaxies and galaxy clusters. Thanks to Planck, we've confirmed that our universe today is dominated by dark energy. there's also a good share of dark matter. Only 4.8% is ordinary matter, out of which the stars, the planets, and we humans are made. But we're still a long way from understanding how this dark universe works. Euclid will observe billions of faraway galaxies. It will reveal how dark matter acts as scaffolding around which galaxies are built, and how dark energy accelerates the expansion of the universe. We happen to live on a planet orbiting a pretty ordinary star in a pretty ordinary galaxy. But how exactly is our galaxy, the Milky Way, laid out? Gaia will tell us. ESA's Gaia Space Telescope is cataloguing more than 1 billion stars to create the most precise map of the Milky Way, showing us not just the positions of the stars in it, but importantly, their motions through it. From this, we can understand how it was put together. But where did the stars and planets come from? This is one of the key questions examined by Herschel. Carrying the largest telescope ever flown in space and observing at far infrared and sub-millimeter wavelengths, ESA's Herschel mission observed the cool universe. It surveyed vast star-forming complexes containing thousands of new suns. Coming back to our own solar system, a trail of water will guide ESA's JUICE spacecraft to Jupiter and its icy moons. Ganymede, Callisto and Europa have vast oceans of water beneath their icy crusts. Somewhere in these oceans, the conditions to support life may exist. Our search for life also leads us to Mars. ESA's Mars Express has found evidence that there was once liquid water on the planet, while methane in the atmosphere today could be linked to microbial life under the surface. ESA's ExoMars program is now underway to continue the hunt. Launched in March 2016, a new orbiter will track the methane in much more detail, and new landing technologies will be tested. And a few years later, a rover will drill into the Martian terrain in search of signs of life, past or present. The SOHO spacecraft is able to determine what's happening deep inside our Sun. It can warn us of eruptions leading to solar storms 3 days before they reach the Sun's surface. Its successor, ESA's Solar Orbiter, will take pictures of the polar regions of the Sun for the first time and study the origin of the fast solar wind. And now to Mercury. BepiColombo will orbit the nearest planet to the Sun to unlock the origin and history of this mysterious planet. Special insulation and solar cell technology are needed to withstand soaring temperatures of more than 400 degrees Celsius. Finally, ESA has reached new heights in exploration with Rosetta, the first ever mission to rendezvous with, escort and land on a comet. Comets are icy time capsules containing almost unaltered matter left over from the birth of our solar system. Exploring this material in detail as the comet evolves, we will change our understanding of the birth of our planetary system and of our own origins. The exciting journey of Rosetta and its lander Philae has captured the world's imagination, bringing space exploration once more to the fore. In the quest to understand our place in the universe, the European Space Programme pools national resources and achieves what no single member state could do on its own. The total cost of ESA's activities is less than the price of one cinema ticket per European per year. A ticket that answers the questions about our place in the universe. A ticket that creates jobs in Europe and maintains a competitive space industry. A ticket that supports European scientists performing at a world-class level. A ticket that fosters European identity and demonstrates European capability and vision.
So now I will give the overview in a time-ordered way. And the first mission that we have on the list here is the SOHO mission that was launched in 1995. Our solar guardian, it's observing the sun continuously. It's in an orbit that is called L1, which basically means that it's flying between the sun and the Earth, and it has continuous views of the sun, and it has also a very good communication link to the Earth. It works therefore as a very good warning system as well on space weather, so it can tell us when there are big outbursts on the sun, and it can warn our satellites to take care if there is a big solar storm. Very interesting as well, it was a big discoverer of comets. As many comets go close to the sun, SOHO was observing them, and it actually discovered more than 1,500 comets already. So this mission has been operational since 1995 and will remain operational as long as it's working. The next mission here is the 1997 launched Cassini-Huygens mission. So that was to unlock the secrets of Saturn and its moons. It is a joint NASA, ESA and ASI mission, ASI being the Italian space agency. And it is really to study in depth the planet, the moons and its magnetic environment, and of course its rings. The Huygens probe was a purely ESA built probe that was attached to the Cassini spacecraft, and at arrival it was released to land on Titan, which it did, and it gave the first images of Saturn moon as done by a probe, which was extremely successful. Then afterwards Cassini started doing its whole tour of the system, and we have there the European experiments on board, still continuing to observe and doing amazing discoveries of the Saturn system all the time. The Huygens delivery to Titan was done on the 14th of January 2005, so already quite a while ago, but it was an amazing discovery. The next mission is back here at Earth, is the cluster mission. It was launched in 2000, and these are 4 spacecraft flying information around Earth, making a detailed mapping of the Earth's magnetosphere. Then we have the Mars Express mission. This was the first European mission to go to Mars. It is providing astonishing high-resolution images of Mars and continues to do so. It's still operational, and it's looking good to operate for the next couple of years. Of course, the spacecraft is supporting other spacecraft arriving at Mars, being either European ones like the ExoMars a week ago, or the American missions. It's also supporting those. Then we get to the Rosetta spacecraft. It was launched in 2004, and it arrived at the Comet in 2014 after making before a number of flybys of asteroids as well. But of course the Rosetta Comet mission is now very well known. It was very visible in the public. Amazing discoveries have been done. We have done the Philae landing, and then we took the orbiter along with the comet around the sun at the perihelion period, where there were amazing activities on the comet and out again. And just a couple of weeks ago we finished this mission with a controlled impact on the comet, where we descended to the surface and took again amazing detailed images of the comet surface. The Rosetta mission is now in post-operation. It means that all the scientists that have been working and operating on Rosetta have now time to actually start really analyzing their data and processing it, putting it into the archive and publishing papers and new discoveries on it. So the fact that the mission is operationally finished, meaning that the satellite has now stopped its operation. Doesn't mean this mission is over. It will take many, many years for the data to be processed by all the scientists. Also, all this data will become available to the public that can look into the archives of ESA. And of course, the new discoveries that are made by the scientists will be published to the public, and it will update the way we look at comets and the origin of our solar system. With Rosetta, we can also say that Rosetta was a special mission because it was a cornerstone mission, and when Rosetta was developed and designed, basically the Mars Express spacecraft and the Venus Express spacecraft were very much based on the Rosetta design. So Rosetta can be seen as really the spacecraft that triggered off a whole fleet of other spacecraft as well. And that brings us to the next mission, which is Venus Express. This was launched in 2005 and operated until 2014. And there the Mars Express spacecraft bus was basically combined with the experiments that were available as spares of Mars Express and Rosetta. So you will see a lot of similarities between Mars Express and Rosetta experiments that were actually put on Venus Express. Venus Express was to basically look into the atmosphere of Venus. There were many really good instruments on Venus Express. We see here an image of the Virtus experiment looking in the night side, the temperature map of the Venus night side combined with a VMC. So we see here the image where we see the Virtus experiments making a night temperature map of the night side of Venus combined with the day side image. It did amazing discoveries. It found these big hurricanes and the poles of Venus, on the south pole in this case, where we had our apocenter. And I will show a couple of videos now to show exactly what happened with Venus Express at the end.
Venus is Earth's closest neighbour. Just over 43 million kilometres away, it's always been an object of fascination for astronomers who believed it to be similar to Earth. In 2005, ESA launched the mission Venus Express, and after 8 years of intensive observation, we now know a lot more about this mysterious planet.
In the early days of the solar system, Venus and Earth must have been very similar. But then something happened, and they took a different route in its evolution. But Venus has developed in a completely different way. The temperature down on the surface is more than 450 degrees Celsius, and the surface pressure is 92 bars. It's almost 100 times more than the Earth. You have clouds that are made up of sulfuric acid, in fact. So it's a very nasty place to be at. And that's one of the big questions on Venus. Why did Venus go that way, and why did we on the Earth go this way?
On Venus, days last longer than years, with the planet taking 243 days to rotate on its own axis and only 220 days to go around the Sun. And it moves in opposite rotation to the Earth, with the Sun rising in the west and setting in the east. Venus also has other interesting characteristics. Not only is the planet subject to strange violent winds that travel at up to 400 kilometers an hour in its upper atmosphere, but it also has massive hurricanes over 200 kilometers across, permanently moving around the poles. All this information and large quantities of raw data about the planet have been generated by Venus Express during its time in orbit. This has been distributed to the widest possible audience, from experts to the general public. But why is it important to study Venus?
Mostly for fundamental science reasons, to learn about not just Venus, but about the solar system, how it evolved. Why is Venus different from other planets like Mars and larger planets?
As Venus Express nears the end of its mission, scientists are making the most of the spacecraft's remaining lifespan by using it to make close-up observations of the planet. These maneuvers, called aerobraking, involve taking daring plunges into the planet's hostile atmosphere only 130 kilometers above the planet's surface. Though apparently risky, the information gathered during these are giving us even greater insight into our neighbouring planet.
We are going so close that we actually sense the atmosphere as a friction against the structure of the spacecraft. And in that way we can measure densities in the atmosphere of Venus that we have not been able to measure for all those 8 years we've been circling the planet. We also measure magnetic fields with a magnetometer, and we measure energetic particles that we find there. So it's a very new type of measurements and very valuable data we're collecting these days.
So to the last, Venus Express is going beyond its original remit and providing us with yet more valuable information. This information not only helps us to understand the evolution of our solar system, but as the planet that most closely resembled Earth in its early years, being of the same size and formed at the same time, understanding Venus helps us to understand more about the potential future of our home planet.
At the end of the mission, we decided to change the orbit of the Venus Express spacecraft by doing aerobraking. This means that we would lower the pericenter such that it would reach the higher parts of the Venus atmosphere, and then this would slow down the pericenter speed, thereby changing the orbit and lowering actually the apocenter and changing the period. This was done with the Venus Express spacecraft, aerobraking technique, and now it will be done again with the Mars TGO orbiter that is now at Mars available. And we can now, thanks to Venus Express, we already had experience with aerobraking in-house. The next mission that we have is the ExoMars mission. It's part of the Mars exploration program. There we have launched in March this year the TGO, the Trace Gas Orbiter spacecraft, along with the lander to Mars. We have seen last week that they both arrived at Mars. The TGO has done a successful orbit insertion, and the lander, which was a technology demonstrator, entered the atmosphere of Mars. There it was able to communicate its data from the descent back to Earth. Unfortunately, not everything went right there, and the landing that was supposed to be a soft landing was not as soft as hoped. So there is data to be learned. It still needs to be analyzed now, but we hope it will give the information to prepare for the next mission, which is the ExoMars 2020, where we will again send a lander to Mars. This time it will not be a technology demonstrator but a real lander, so we need to make sure that we get our landing techniques really right for this one.